Hello everyone, welcome. We are going to be looking at our practice for lesson 2.11. So on the first slide, as always, you'll see that lesson summary. We're talking about absolute value, and the absolute value of a number is its distance from 0 on a number line. Either equations with absolute values will have two solutions because there's often going to be two numbers that are a certain distance from 0 or from a number. For example, the equation x plus the absolute value of x plus 3 equals 4 has two solutions because x equals 1 and x equals -7 both have an absolute value of 4, right? If we plug it in for x. 1 plus 3 is 4. The absolute value of 4 is 4. And -7 plus 3 is -4, and the absolute value of -4 is 4. So we can determine the solutions using a number line, or we can also solve two equations. To determine the solutions of an inequality with an absolute value, we can solve for the boundary points and determine whether the boundary points are included or not included, and then test values between the two boundary points to decide which value makes that inequality true. And then we can graph all of our solutions. So let's take a look at slide 2. It says click and drag to graph all the solutions of the inequality absolute value of x is less than or equal to 3. So we want to be 3 spots away from 0, right? We're looking at the distance from 0. So the numbers that are 3 spots away from 0 are 3 and -3. Now we do have or equal to, we have that line underneath, so we want to make these circles solid. And then when it's less than, we're shading in between, because these are all numbers that are either 3 spaces away from 0 or less than 3 spaces away from 0. So there's our solution for problem 1. When you're all set, push to problem 2 on slide 3. It says, click and drag to graph the solutions to the inequality the absolute value of x plus 2 is greater than 4. Now, remember when we see plus signs, we want to think that this is x minus a -2 is greater than 4. Because when we have minus a negative, it becomes that plus. So we're looking at the distance from -2. And when we focus on -2, we want to be 4 spaces away from -2. So 1, 2, 3, 4 gets us down to -6. And then if we go to the right, 1, 2, 3, 4 gets us to +2. This is just greater. It is not or equal to, so we're going to leave our circles open. And then if we're looking for values that are even further away than 4, we want to shade on the outside with the arrows pointing in either direction. Beautiful. For the next slide, so that's how we can think about it when we have an absolute value inequality written like this. On slide 4, I'm going to do it a little differently. I'm going to solve the two inequalities. So we have the absolute value of x minus 5 equals 1, right? So if we were to solve this, this means that x minus 5 has to equal 1, or x minus 5 has to equal a -1, right? What that means is this absolute value, what we solve in there, if it simplifies down to 1, the absolute value of 1 is 1. And the absolute value of -1 is 1. So we can make our two equations like this to solve for our boundary points. As we start solving, we just use our opposite operations, add 5 to both sides, and we get x equals 6. On the right, when we add 5 to both sides, -1 plus 5 is 4. So our 2 points are going to be on 6 and 4. And again, if we think about this using the graph like we did for previous questions, The distance from 5 is 1 away. So 1 away from 5 is 6. 1 away from 5 in the other direction is 4. This is equal. There's no greater, there's no less than, it's just equal. So we just want to fill in those circles. Those are the two solutions here. So what that means, again, if we plug them in for x, so if we had, if x equals 4, 4 minus 5 is -1, and the absolute value of -1 is 1. If x is 6, the absolute value of 6 minus 5, well, 6 minus 5 is 1, and the absolute value of 1 is 1. So these are our two solutions, 4 and 6. Beautiful. When you're all set, push ahead to the next slide. Click and drag the graph to graph all the solutions to this inequality. So we're looking at the distance from 3. The distance from 3 is 2 to get our boundary points. So we go to 3. 2 above 3 is 5. 2 below 3 is 1. So there's our boundary points. It is greater, or it looks greater, right? But there's no or equal to, so our circles are going to be open. We may want to flip this and write it with the absolute value of x minus 3 in the front. Notice that less than is pointing to the absolute value of x minus 3, and then 2. So you'll notice when you flip it and read it in the ways that we have been, this distance is less than 2. So it's going to be in between the 2 points. In between the 2 points. Beautiful. And go to slide 6. What value of p would make x minus p greater than or equal to 4 match this graph? Oh, so we know that it's like balanced on the left and the right, because remember we count like 4 to the left, 4 to the right. So let's look at this distance from -5 to 3 is a distance of 8. So it's going to be right in the middle. So since our distance is greater than or equal to 4, 1, 2, 3, 4 gets us here. 1, 2, 3, 4, that works as well. So it's always going to be balanced like this. We have 4 on the left, 4 on the right. So we were looking at the distance from -1. So that would be x minus -1, which of course we would see written as x plus 1 in the absolute value bars. Beautiful. Slide 7 when you're ready. Which inequality solutions are shown by this graph? Ooh. I'm going to have you try this one on your own. I want you to work through this one, figure out which inequality we have here. Notice where those test points are, and think about what's in the middle, what's in between -1 and 5, because we're finding that halfway point. Okay. And then push ahead to the next slide. It says list 3 numbers that are not solutions to x. The absolute value of x plus 1 is greater than or equal to 2. So if we think about this, what this means is what's inside these bars is going to have an absolute value of 2. So that means that x plus 1 is going to either equal 2 or x plus 1 is going to equal -2. If we subtract 1 on both sides, we get x equals 1. And if we subtract 1 over here, we get x equals -2 minus 1 is -3. And it's greater than, so we're going to have, if we're thinking of our number line, we have -1 in the middle. 1, 2, 3. 1, 2, 3. So here's -3, and here's +1, if I just fill them in. Beautiful. So we're going to have closed circles on 1 and -3. And then it's greater, so we want distances that are greater than 2. So we're going to be shading to the right and to the left, opposite directions. So things that would not be solutions are going to be in this middle area. So we could think of -2, -1, or 0. We could also think of decimals like 1/2 or 0.75 or -2.5. Anything that's between -3 and 1 and not including -3 and 1. Beautiful. Okay, let's look at the next slide when you're ready. Omar is thinking of a number somewhere on this number line. Here are some guesses from Omar's friends. No guess was more than 5 away. Only one guess is correct. What is Omar's number? Explain your thinking. Okay. So if someone guessed 1, we can think about it. 1, 2, 3, 4. This is 5 away. And here, these are 3 guesses that are more than 5 away. So that's not going to work. If someone guessed 3, 2, 3, 4, 5. So here, these 2 guesses are more than 5 away. So 3 is not correct. If someone guessed 6, 1, 2, 3, 4. 1, 2, 3, 4, 5. Ooh, so that looks like it works. It looks like 6 is the only one that doesn't have a guess. So let's just double check. Here's 7. 5 away. We're good to the right. 1, 2, 3, 4, 5. Ooh, but that number 1 is more than 5 away. So that wouldn't work. And with 9 and with 10, obviously if we go 5 away, 2, 3, 4, 5, we're going to miss both 1 and 3. So 6, so we can say that the number has to be 6. It is the only guess that every other number is no more than 5 away. Beautiful. Okay. All right, let's look at slide 10. Is this sequence arithmetic or geometric or something else? So we're cruising back, doing some spiral review. We see that this is going up and over by the same amount each time in a straight line pattern. That is arithmetic, right? We're increasing by the same amount by 4 each time, and we're seeing that linear function. So looking at that same graph here, what is the value of the 5th term? So, oh, this is a different graph. So our first term is 5. Our second term is 9. What is the 5th term going to be? Go ahead, take a moment, and make sure you're plugging that in. And then finally, on the last slide, what is the value of the nth term? So this is a throwback. Think about that initial value plus the constant difference times n minus 1. Or we can say the 0 term plus the constant difference times n. So take a second, find those values, plug it in, feel nice and cozy, and then check your reflection slide on slide 13. And make sure you are using that space to ask a question or share something that you're proud for. That is an important slide. Make sure you're filling that in too, okay? If you need any support, reach out to me. Let me know how I can help you out. Otherwise, see you in the next video. Bye, everyone.